Hi everyone, welcome back. Mr. Canistero here. In today's video, we're going to do a classic problem projectile motion, the projectile launched horizontally off a cliff problem. So in the projectile motion, you see this problem over and over and over again. Typically, the same strategy for solving this problem works almost every time, no matter the type of problem provided. So first off, if you're in projectile motion or you're looking at problems, what does this horizontally launched off a cliff problem look like? Well, you always start with a person or something on the top of a cliff, a tower or something, kicking or throwing a ball off, and it's always launched horizontally. So you'll either see an arrow or it'll say launched horizontally, etc. And then the ball is going to proceed to fall down towards the ground. And most of the time, they're concerned with the following: either the time it takes to reach the ground, or how far from the base of the cliff does the ball land. And so that's a measure of a horizontal distance. So what are the key features of this problem? Well, the key feature, the absolute biggest one, is because the ball is launched horizontally, whatever that initial velocity is given the problem, that is entirely in the x direction. So it's entirely an x component. Also, whatever the height of the cliff or tower is, that is entirely in the y direction. So you're given a distance in the y direction. Finally, most of these problems take place on Earth. Another key feature, you're going to use the acceleration of gravity. So how to solve it? When you solve any projectile motion problem, you really want to make a table of all of your x and y information. So I always write down, what is my distance in the x direction? What is my velocity in the x direction? In my y direction, I put things like, what is my initial velocity in the y direction? What is my final velocity in the y direction? I just write everything down that I could possibly have. Notice how I'm writing down initial, final, because in the y direction, we know that there is an acceleration of gravity, namely negative 9.81 meters per second squared. In the x direction, we know it moves at a constant speed, so we only ever deal with distance and velocity variables for the x direction, at least in the Regents level physics. Finally, I put time in the bottom with an equal sides for both ways, because our goal in all projectile motion problems is always solve for time, because time is the one thing that connects the x and the y together, that unites them. And our goal is always solve for the time one way and then use it somewhere else. So let's go ahead and try an example problem. So in this example problem, the problem stated is, the diagram below shows a student throwing a baseball horizontally at 25 meters per second from a cliff 45 meters above the level ground. And the question is, approximately how far from the base of the cliff does the ball hit the ground? And of course, we're going to neglect air resistance. So what we're going to do is we're going to use the kinematic strategy that we talked about in previous videos. I read through the problem once. I'm going to read through it again and get an idea, because I know this is projectile motion. I'm just going to underline some of the important stuff. So the ball is launched horizontally, so that's really the thing that's indicative that this is a horizontally launched projectile problem, at 25 meters per second from a cliff 45 meters above the level ground, and we're trying to find how far from the base of the cliff does it land. So first off, the horizontally, this is a measure of my Vx, so the Vx is 25. I know that my 45 meters, that's a measure of the distance in the y direction. And the how far from the base of the cliff, what we're looking to solve for is a distance in the x direction. So for all projectile motion problems, I make a table. So I make my x and y table, and I just start filling out anything that I know. Well, I know my velocity in the x direction is 25 meters per second. I know that my distance in the x direction is what I'm trying to solve for. I know, because this is a horizontally launched projectile problem, and one of the key features of it is, if it's launched horizontally, the initial velocity in the y direction is always 0. That's a key feature of all horizontally projectile motion problems. I know my distance in the y direction is 45 meters. I know the acceleration is, of course, gravity, so 9.81 meters per second squared. So you see here, our goal is to solve for the distance it travels in the x direction. In order to get that, we need to have a time. So we now look over on the y side and say, well, I have a VIY, a distance, an acceleration. I need to solve for a time first. So our first goal of this problem is, let's just go ahead and try to solve for time. So let me move everything over a little bit. Ooh, don't want to move that. Let's try it again. Oh, it doesn't want me to. That's all right. I'll just do it over here on the side. So looking at my reference table, if I have a VIY, a distance, an acceleration, and a time, the equation that allows me to solve for time is d equals VIT plus 1/2 AT squared. Now I go ahead and substitute in. Now, because I already wrote my units in the table, I don't need to write them again. Once is all you need to do it. So 45 is 0 times time plus 1/2 gravity, which is 9.81 t squared. So the 0 t term, that goes away. And so what I'm left with is 45, not 49. 45 is 4.905 t squared. So I divide by 4.905 on both sides. And so I get t squared is 9.17 seconds squared, which means t is the square root of that. So square root both sides. And I get a time of 3.03 seconds. Awesome. So I've solved for my time using the y side. I now go ahead and fill it in my table. So I write 3.03 on this side and 3.03 on this side. So the next step is we're going to go ahead and finish up the problem. We're going to solve for the distance. So I'm going to move this stuff out of the way. And so now that I have a time and a velocity, I can solve for the distance. So the only equation we use in Regents physics ever to solve in the horizontal direction is our old buddy. Velocity is distance over time. I'm just putting the x values, the x subscripts in there just for clarity. I plug in what I know. I know my velocity is 25. Distance is what I'm trying to solve for, and I have a time of 3.03 seconds. I cross multiply because 25 is always over 1 because there's no denominator 1. And so solving, I get a distance in the x direction of basically 3 times 25, so basically about 75 meters. And they said approximately, so I'm just going to go ahead and keep it as a whole number. And so we've solved the problem, projectile motion problem, for the horizontally launched projectile. Now, no matter what the problem is asking, they might ask you to solve for time, they might ask you to solve for velocity. By applying this basic strategy of kind of drawing the picture, underlining, making your table, solving for time, and then using time to kind of get whatever the missing variables you need, you can basically solve any projectile motion problem given to you. But again, really the key feature, underline, find an equation, take your time, check your work. All right, thanks guys. Hope this helped. I'll talk to you guys soon.